All right, let's go deeper with the AI and studying academical papers. So I have just studied a paper which is called Playing FPS games, so first-person shooters games with deep reinforcement learning, which is quite fresh. This article is just like from a few months ago. It was published, I don't know, 4 months ago. Anyway, they came up with this idea that you may have heard that AI is already good at playing games like from the 80s, from Atari, where it's all 2D and all so two-dimensional, and all information is visible, like Arkanoid. And with this and reinforcement learning, the AI is actually pretty cool. It's able to learn. Given the training phase, it's able to learn to play those games pretty perfectly. In the machine learning world, as far as I learned so far, those are the two phases usually. You have this learning phase, so you give the training phase, you give some huge amount of data to the machine to train, and then you have the test phase, so you're actually using the machine now to see how well it behaves. And in this paper, they have described how they built a model to play Doom, Doom as the first-person shooter. They chose Doom because there is this project called DoomViz, where they give you API for actually playing Doom, as a script, as a bot. So that's great. I didn't know about it. And their first approach was based on a baseline DRQN model, which more or less stands for deep Q networks with deep recurrent Q networks. However, when they just use this model, they've seen that the visual information from Doom, like the pixel by pixel, they received a frame, so exactly what humans also do. The machine wasn't playing very well. It was quickly shooting, quickly getting out of ammo, and it was very hard to tweak. So they did actually augment the game to try to make it easier for the machine. And I think it nicely shows the problem, like how important is that not only the data, but how labeled is the data. And here they augmented the game to not only tell us about the rate and the pixels, but also whether a specific opponent or an entity opponent is visible right now. So this is like a hack here. And just receiving this information, and only during the training phase, it wasn't used in the test phase, obviously. So when they played with real bots or with real people, it wasn't used. And only adding this actually improved the enemy detection accuracy by 90%. It basically became like the most efficient Doom bot during death matches. That was mostly for the death match. So it shows like how little things have impact here. Just adding one information to make it easier to train resulted in a huge improvement of the algorithm, and I find it super exciting here. And we are already talking about exciting things, because this whole thing with deep Q networks, this is basically the same algorithm that also has beaten the world-class Go players. So something that was meant to be like impossible by machines, it happened exactly with deep Q networks. So yeah, I'm getting deeper into this stuff. So probably more episodes like this soon. Thanks for listening.